Today's lesson is on similar polygons. Similar polygons are polygons with the same shape but different size. You will find that polygons are similar if the corresponding angles are congruent and the corresponding sides are proportional. Take a minute to pause the video if you need to catch up on taking notes, okay? So now the ratio of the corresponding sides is called the scale factor. And if polygons are similar, then their perimeters are also proportional. Now we'll take a few examples later on and investigate this concept. Now we're going to look at a couple of examples here. We have triangle ABC, which contains side measures of 8, 10, and 18. We're going to compare this to another triangle labeled as DEF with side measures 12, 15, and 27. Now the order matters. If you're going to be looking for the scale factor of triangle ABC to DEF, we want to make sure that the sides are corresponding. So I'll take one side measure from ABC. I'll take the smallest side measure, which happens to be 8. Now, the smallest side measure on this triangle will correspond to the smallest side on the other triangle. Now, between 12, 15, and 27, 12 is the smallest side. So we're going to compare 8 to 12. Now, you can do this one of two ways. You can write it with a colon, or if you'd like, you can write it as a fraction, 8 over 12. So if that helps you reduce, you can do this. And we get 2/3. So the ratio of ABC to DEF is 2/3. Let's change this question around. If I were to ask you, what is the scale factor of DEF to ABC? Now you work the other way. So you would compare 12 to 8 instead, and you would get 3 to 2. Now, you don't have to choose the smallest side measures, but you do need to choose corresponding sides. So if I wanted to choose instead the largest side measure, let's say 18 and 27. And if I compare 27 to 18, it still reduces down to 3 to 2. So what you're going to find is that all the corresponding sides are in proportion. They're going to have the same scale factor. So we have 3 to 2 here. So now we're going to compare the perimeters. On triangle ABC, if you add up these sides of 8, 10, and 18, you'll find you'll get 36. On triangle DEF, when you add 12, 15, and 27, you will get 54. Now let's compare these perimeters. We're asked, what is the ratio of the perimeter of triangle DEF to triangle ABC? If we compare 54 to 36, we're going to find that these measurements reduce down to 3 to 2. Now, take a look at this. The ratio of the sides is 3 to 2. The ratio of the perimeters is also 3 to 2. So this is something to keep in mind as we continue on in our lesson. Now we're going to take a look at similarity statements. The symbol for similarity looks like this. A valid similarity statement must match corresponding angles and sides. So we want to write a similarity statement for the triangles above. So let's go back to that diagram. Now angle A corresponds to angle D. Notice they have one arc, showing that those angles are congruent. So we're going to list D first. B corresponds to E, and C corresponds to F. So our similarity statement is written as triangle ABC is similar to triangle DEF. This does not mean the triangles are congruent. It means their sides are in proportion, and it means that their angle measures are the same. So let's investigate an example like this. If you are given the similarity statement, you know which sides and angles are corresponding. So take a look here. J is listed first and P is listed first in that similarity statement. So J is congruent, angle J is corresponding and congruent to angle P. And angle K is corresponding and congruent to angle M. And finally, L is congruent and corresponding to angle N. So we're going to list the angles that are congruent in this space. Now the sides are not congruent. Since the triangles are similar, the sides are in proportion. So what we're going to do is we're going to show which sides are in proportion. So we're going to compare the sides here. JK can be compared to PM, and KL can be compared to side MN. And finally, side JL can be compared to PN. So what this would mean in the future is we found that all the ratio of the sides are in proportion. So in our last example, we saw that the ratio of the sides from one triangle to the next was 2 to 3. So if you took every single side measure, they all reduce to the same exact fraction. Now I want you to try this one on your own. I'll give you a head start on this as well. But looking down to number 4, I'd like to work this with you. If the figures below are similar with a scale factor of 2 to 3, and you have to find the value of x, what might be a good idea for you is to set up a proportion. Now you can see this one is the smaller one, so that gets the 2, this gets the 3, all right? So we're going to set up a proportion. If we say 42 over x, we'll write 2 over 3 on the other side. So we want to compare the side measures. So we set them equal to the ratio values that we've been given in the question. Now at this point you can cross multiply and you'll get 2x equals 3 times 42. And so you get 126 equals 2x, and finally divide by 2 and you'll get 63. So the side measure, x, equals 63. On number 5, same concept. The figures are similar with a scale factor of 6 to 5, which means that their side measures will reduce down to 6 to 5, which again you can rewrite as a fraction. And so the larger one, I'll put 6 and 5 inside. I like to mark them up like that so I keep tabs of what the ratios are and what's corresponding. And so x is going to be on the numerator because it's on the same triangle where the 6 is located, and then 28 will be on the denominator. And same idea, you'll go ahead and cross multiply. And in some cases like this, when you actually solve, you might end up finding that you have a decimal, and that's okay. All right, so go ahead and finish that up on your own, and let's see what else we have here. Okay, so for this one, example number 6, you're given that the triangles are similar, and you're told to find the value of x. So this is where the corresponding sides can be found. You're going to look at this similarity statement. So we're comparing sides AB, which is 25 over 20. So I'm going to write it like this first, AB over BC. I'm going to look at the similarity statement so I can find out which sides are corresponding to AB. And I see in the similarity statement it's DE and it's EF. So now, as long as I have this similarity statement translated into now a proportion, I take all the measurements and I substitute into those fractions. So I'll have 25 over 20, and on the other side, I'll have x over 28. Now the order does matter. Remember, the sides are in proportion. So I wouldn't want to have 28 over x being compared to 25 over 20. So really pay attention to that similarity statement that's been given in the question. Now, cross multiply, you'll get 20x equals 25 times 28, and go ahead and continue your algebra to solve. On the next problem, you have a quadrilateral, but this shouldn't stop you. As long as you have the similarity statement, we know exactly what we're comparing. So take a look here. We have two side measures and two side measures here. So we want to figure out which way to set up the fractions. So let's start off with the 40 and the 32. I want to set up WZ over ZY. Now I look at the similarity statement to help me figure out what's corresponding to WZ. It looks like it's PS. And what's corresponding to ZY looks like it's SR. So now all I do is take this information from the triangles and substitute those measures where they belong. So WZ is 40, ZY is 32, PS is 75, and SR is X. Now, same thing, cross multiply, solve, and you will be done. Once you get to these examples, you're going to be dealing with expressions that involve binomials. Okay, so there might be a little bit of distributive property happening in these cases. So let's take a look. Again, this is really important to us. Let's look at the sides we're comparing. We'll be comparing GM over GA on one triangle. And let's take a look at the similarity statement to figure out what goes on the other side. If I'm looking at GM, XD corresponds to that. And if I'm looking at GA, I'm looking right over here, it's KX. So let's go ahead and substitute our measurements. We get 36 over 32. XD is X plus 6. And KX is X plus 3. Now, when we cross multiply, this is where distribution is going to happen. We have 32 times X plus 6. And we have 36 times X plus 3. So take a moment now and distribute those values. So 32 times X, we'll have 32X. 32 times 6 is 192. We'll do the same on the other side. We get 36X plus 108. All right, and now we have this linear equation which we have to solve. So we'll go ahead and transpose 32 to the other side. All right, so we get X equals 21. If we look back at the question, that is all you had to find. Okay, so I'll leave you with the rest of these problems. You're going to finish up page 1 and page 2 in the packet. If you have any questions, please email me.